All right, this is angles, and this is kind of part one, maybe section, 1.4. So let's take a look at this. This would be angle ABC. So talk about naming angles. Angle ABC. Angle ABC. Let's talk about this angle right here, right? That angle. Now, what is congruent with angle ABC? Well, turns out that angle CBA is the same angle, right? So we can talk about angle ABC and angle CBA are the same thing. Okay, the vertex is B. The sides are the ray, so rays, ray BC and ray BA are the sides here. Point P, we would say, is interior. Naming them is pretty easy. What does it mean for two angles to be congruent? Well, that means they're the same measure. So they're both 40 degrees. And again, the congruent symbol is the same for it is for segment. The measure, well, we can start talking about how we measure those with a protractor. Generally speaking, that looks like about 90 degrees. That's probably around 45. Again, just giving you an idea. Some angle like that might be 135. What about, this is kind of a silly angle, right? All the way, well, that's 180, and then all the way around, well, that's 360, right? You talk about 360, for a skateboarder or a snowboarder or doing a 360 dunk, right? You're spinning all the way around, right? Half of a spin is 180, quarter of a spin is 90. That's about a 45 degree angle. We've certainly seen, angles before, but the measure of the angle is the size of the angle, and we typically, at least at this point in your career, talk about it in degrees. Okay? All right, types of angles. Acute. Well, an acute angle is less than 90 degrees. Obtuse is more than 90 degrees. A right angle is exactly 90 degrees, and then a straight angle is 180 degrees, and there'll be other ways to even talk about that. All right, the angle addition postulate. Don't want to overcomplicate the world, man. So let's say we have something like this. Okay, we have angle 1 and angle 2. What do you think if you take the measure of angle 1 plus the measure of angle 2? What would it equal? Well, it better equal the total. From this ray all the way to that ray, just like the segment addition postulate, we have an angle addition postulate. To me, I'm not even sure we really need to be a postulate. I mean, I know it's something that we can just say is true, a postulate, we don't have to prove it, but hopefully it is obvious at this point that if I take this angle plus this angle, I get the total angle, and then we can use it to solve questions, right? There can be silly questions where you have something like that, and you have, I don't know, this is 6x, and that is 8x, I don't know, what, minus 20 or something. Okay, and you can add those together, and they have to equal the total. So if I told you the total, then I would tell you then kind of everything. So what if then, I don't know, what do you think the total is? Maybe 120, something like that. What if I told you that was 120 degrees? Okay, if that was 120 degrees, using the angle addition postulate, you would know that 8x minus 20 plus 6x would have to equal 120. And so that's 14x would have to equal 140, and x equals 10, which means this angle is 60 degrees, and it turns out the other angle is 60 degrees. Okay, now if that happened, what could you say that this line is? Boom. Then it'd be a bisector. Okay, a bisector creates two congruent angles. Now again, don't get these confused. This is always true. Little angle, other angle equals total angle. The bisector is just like saying in the segment stuff about midpoints, right? If you have a segment and you break it up, you always know if this point is between, even if it's not the midpoint, that this piece plus this piece equals the total. But if you know that this is a midpoint, or if you knew that this line bisected the segment, then you know that these two things are congruent. Same thing. This angle plus this angle always equals the total. If you knew that this was a bisector, then you could have set 6x equal to 8x minus 20. And you could have said 20 equals 2x, and you would have got x equals 10, and then you got 60 and 60 again. Again, different. If you know it's a bisector, you know these two angles are equal. So set them equal. If you don't know it's a bisector, you still know that this angle plus this angle equals the total, which is what this said. Okay, so again, reviewing this. We have some notation stuff, how we name this. Angle ABC. That's the vertex, right? That's the middle one. If someone just said angle B, they almost certainly are just talking about that angle as well. But really, 3 letters is the more proper way to talk about it. P is interior. Point over here would be exterior, meaning kind of outside versus inside. The sides of an angle are rays. Right? These are rays. Congruent angles have the same measure, and I kind of walked you through. Like that looks like 90 if I'm estimating. That looks like 45. That maybe looks like 135, and that looks like 180, right? We could use a protractor to actually measure them, or I could label the thing and tell you it's 90 degrees, okay? And then we have the angle addition postulate, just like the segment addition postulate. We have an angle bisector, just like we had a bisector in segments. In segments, it made that congruent to that, and in angles, it makes this angle equal to that angle. Again, if angles are equal, set them equal. If angles aren't equal, then do first one plus second one equals total, which is what something like that did. Okay? Hopefully this is enough to kind of get you started on some of that angle stuff, but we'll get a protractor and we'll teach you how to measure angles as well. That'll be probably a different video.